Welcome to our channel. In this video, we're going to cover the most expected and important operating system questions for 2025. This is perfect for students preparing for exams, as we'll walk through each module with key questions, short explanations, and must-know definitions. Let's get started with Module 1, Operating System Overview. Module 1, Operating System Overview. 1. Explain the objectives and functions of an operating system. An OS manages hardware, runs applications, and provides a user interface. Its core functions include process management, memory management, file system handling, and security. 2. Compare and explain the layered, monolithic, and microkernel structures. These are architectures of OS design. Each offers different levels of complexity, performance, and modularity. 3. What are system calls? System calls allow user programs to interact with the OS. Common examples include read, write, open, and close. We'll explain this with diagrams and real-world examples. 4. Describe the Linux kernel and shell. The kernel interacts directly with hardware, while the shell takes user commands and communicates with the kernel. 5. Differentiate between kernel mode and user mode. In kernel mode, the OS has full access to hardware. In user mode, access is limited for safety. Module 2, Process and Scheduling. 1. Define a process. A process is a running program. We'll explore the process state diagram to show how a process changes states during execution. 2. What is a process control block (PCB)? The PCB stores all the information about a process, like its ID, state, program counter, and CPU registers. 3. Compare preemptive versus non-preemptive scheduling. Preemptive allows interruption, non-preemptive runs to completion. Each has pros and cons depending on system needs. 4. CPU scheduling algorithms. We'll solve examples using FCFS, SJF, round robin, and priority scheduling, complete with Gantt charts. 5. What is a thread? A thread is a lightweight process. We'll compare user-level threads ULT and kernel-level threads KLT with diagrams. 6. Explain multithreading models. Understand many-to-one, one-to-one, and many-to-many models and where they are used. Module 3, Process Synchronization and Deadlocks. 1. What is the critical section problem? It's the problem of safely sharing resources. Solutions like Semaphores help prevent conflicts. 2. Producer-consumer problem using Semaphores. We'll walk through this classic problem with simple code and explanation. 3. Deadlocks. Definition and conditions. Deadlock happens when processes wait forever. We'll cover the 4 necessary conditions. 4. Deadlock prevention techniques. Avoid deadlocks by breaking one of the 4 conditions, like using resource ordering. 5. Banker's algorithm. We'll solve a numerical or conceptual problem step by step. 6. Dining philosopher's problem. A synchronization challenge solved using semaphores and resource ordering. 7. Resource allocation graph (RAG). A visual way to detect and analyze deadlocks. Module 4. Memory management. 1. Fixed versus dynamic partitioning. We'll explain both with diagrams and compare their pros and cons. 2. What is paging? Paging splits memory into fixed-size blocks. We'll show how logical addresses are translated into physical addresses. 3. Paging versus segmentation. Paging is memory-based, segmentation is logical. Both have their use cases. 4. Memory allocation algorithms. We'll solve examples using first fit, best fit, and worst fit. 5. Virtual memory and demand paging. Virtual memory extends RAM. Demand paging loads pages as needed, improving efficiency. 6. Page replacement algorithms. We'll solve problems using FIFO, LRU, and optimal strategies. 7. What is thrashing? Too many page faults can lead to thrashing. We'll explain how to detect and reduce it. 8. Translation look-aside buffer (TLB). A hardware cache that speeds up address translation. Module 5. File management. 1. File access methods. Learn how files are accessed sequentially, directly, or using an index. 2. File allocation methods. We'll compare contiguous, linked, and indexed allocation methods. 3. Directory structures. Understand single-level, two-level, tree, and acyclic graph structures. 4. File sharing and protection. We'll explain how operating systems control access and permissions for shared files. Module 6. I/O management and disk scheduling. 1. Disk scheduling algorithms. We'll solve numerical problems on SSTF, scan, cscan, look, and clook. 2. Compare scan versus look. Both move the disk arm in one direction but differ in how far they travel. 3. I/O system structure. Learn how the OS manages I/O devices and transfers. 4. Disk organization. We'll explain how data is stored and accessed using diagrams. Short notes, frequently asked definitions. 1. Context switch, when the CPU switches from one process to another. 2. Starvation versus aging. Starvation is indefinite waiting, aging is a solution. 3. Convoy effect, delay caused by one slow process holding up others. 4. Multi-threading models, overview of how threads map to processes. 5. Inode structure in Unix, Linux, data structure that stores file metadata. Bonus. Miscellaneous and system understanding. 1. Shell script examples. Simple scripts to copy files, calculate factorial, or count words. 2. Internal versus external commands in Linux. Internal commands are built in, external commands are separate programs. 3. 5-state process model, includes ready, running, waiting, and 2 suspended states. 4. Types of schedulers. Explore long-term, short-term, and medium-term schedulers with a diagram. 5. Define concurrency. Concurrency allows multiple processes to run seemingly at once, key in multitasking systems. Thanks for watching. If you found this helpful, don't forget to like, share, and subscribe to stay updated with more exam-focused videos. You can find all questions listed in the video description for quick reference. Drop your doubts or topic requests in the comments, we love hearing from you. Until next time, keep learning and all the best.